Hello world, welcome to Sphinx channel. Before we start, if you like this content, subscribe my channel, like this video and tell me your opinion in the comment below. This video is part 4 of Network for Hacking series. Let's start. Let us start with Domain Name Service Server, that is a DNS server. Now what is a DNS server? A domain name service. DNS server is one of the most important servers in your work in the internet as well. Now why it is so important? Because without a DNS server you would have to type http://IP address instead of simply entering www.google.com. So it allows that you can pretty much think of the DNS system as the phone book of the internet, right? It is better to remember the names than to remember IP addresses. So DNS server consists of a host name that is a device which has an IP address, and on the internet it is a part of what is known as a fully qualified domain name, FQDN. So basically FQDN is a combination of host name and domain name, and the process of finding the IP address for any given host name is known as the name resolution process. As the name suggests, you give the name and the web server or the DNS server specifically will return the IP address that is associated with that name, that is known as the name resolution. Now, which are the top-level domains in use now on the internet? Domains are arranged in a hierarchical tree structure. The following list includes some of the top-level domains. In current use is a commercial organization: Amazon.com, Google.com, Microsoft.com, Apple. Then is an educational establishment such as a university: Stanford.edu, MIT.edu, then California University.edu. Gov, it is a branch of the US government, but in your country specifically. Let's consider the example of India from where I am. www.passport. Gov, and you have seen that after Gov sometimes there are initials of your country, which means that under government the domain is given for specifically for your country. Then is int, an international organization such as NATO or United Nations. Net is a network organization and is a non-profit organization. Now your local internet service provider is probably a member of the net domain because the internet service provider comes under the network organization and your company. Or let's say if you're working in a company, then you come under the part of. And if you are studying in the university, and if your university has a website, they come under then education establishment in other parts of the world. The final part of the domain represents the country in which the server is located. For example, CA for Canada, JP for Japan, UK for Great Britain, and ION for India. Now, well over 130 countries are represented on the internet. But for most of the websites that you have seen on the internet, the .com domain is by far the largest, followed by the domain. So .com is the largest domain, followed by the domain. So this is first, this is second, and there are 130 countries throughout the globe. For example, www, let's say Google in. So what does this in means? It means that this server is located of. The server of Google is located in India. So whenever someone from India accesses or tries to ask a query on Google, the request is forwarded to the server that is located in the Indian continent, Indian subcontinent. Okay, now, in the next lecture, we'll have an introduction to the different record types, and I'll tell you what a record means in the DNS server. Okay, in the last lecture, we had a brief introduction to the DNS server. Now, to complete unqualified domain name service names that will be used to search and submit DNS queries at the client for resolution, you must have a list of DNS suffixes that can be appended to these DNS names. For DHCP clients, this can be set by assigning the DNS domain name option and providing a single DNS suffix for the client to append and use in searches. Now, in this lecture, we are going to talk about the DNS record types. Address mapping record. A now host is called an A record, and what it gives is it gives you the IP address of a domain or a host. In IP version 6, it is called a quad or 4 times a record. Now records. So these records let me take the pointer. Yeah, so these records resolve the host names to IP addresses. But what happens if you know the IP address and then you want the host name? Well, there is a record for it, too. That is a pointer record which formulates back or points back to the name. Now canonical name record, that is the CNAME record. Now, the CNAME record can be used as alias to a host name or another host name. When a DNS client requests a record that contains a canonical name which points to another host name, the DNS resolution process is repeated with a new host name. So basically, CNAME is used to point to another host name. And then this process continues where finally the new host name is obtained. The next is the mail exchanger record. That is the MX record. The MX record points to the mail exchanger for a particular host. Now, DNS is structured so that you can actually specify several mail exchangers for one host. So basically, the MX record is involved in sending and receiving emails through a particular server name server records, that is, the NS records. Now, NS records specifies that a DNS zone, such as, let's say google.com, is delegated to a specific authoritative name server and it provides the address of the name server. So what is authoritative name server? Authoritative name server is basically, let's say, www.google.com. Then Google is the authoritative name server.com is the root level server. We have seen the different domains or the different com designations in the last lecture. And I've told you that the domains that is top level domains are the root level domains and com is one of the root level domain, and therefore, authoritative name server is Google. Reversed lookup pointer records allows a DNS resolver to provide an IP address and receive a host name. So what a record does basically, so what a record does, so what this record does is basically you give the name and it will return an IP address. Okay, it will return an IP address. But in case of this reverse lookup pointer, you give an IP address. So it allows the DNS resolver to provide an IP address and receive a host name. So it's a vice versa process. Next is certificate record, that is the cert record. Now, the certificate record stores encryption certificates, for example, PKIX, that is Public Key Infrastructure, SPK, PGP, and so on. Now, when you go to www.google.com in the web bar, suppose this is the web bar, and here is www.com, there is a small lock here, okay? If the certificate or if this website is protected, when you click here, there is a box which tells you that certificate is stored. Now, where is this certificate stored? The certificate is actually stored in the certificate record. Okay, next is service location, that is the SRV record. SRV record is a generalized service location record which is used for newer protocols instead of creating protocol-specific records. Then is the TXT records. TXT records are used to provide authentication of mail sent and received by the same email system. It basically works on the sender-receiver policy. For example, if any one of you has created a website or they host the website, they might be knowing that when you want to verify your website, you have to add the TXT record in place and you have to verify the TX record after a certain point from the original server. And then if that is verified by the mail exchanger, then only you are allowed to send and receive third-party emails on your server. The next is the SOA record, that is the start of authority. Now, this record appears at the beginning of the DNA zone file, and it indicates the authoritative name server, for example, Google for the current DNA zone. It also provides the contact details for the domain administrator, domain serial number, and information on how frequently DNA information for the zone should be refreshed. Now in the next lecture, I'm going to discuss about the different types of DNA and external and internal DNS. But before going ahead, we are going to use a DNS dumpster, that is Dumpster Practical, where you will find how to calculate or how to find out the information from a domain name server. It's a great practical and I recommend you to not skip the practical. I will see you in the next lecture. Now, let us move on to the last lecture of the DNS server. In this lecture, we are going to see the different types of the DNA. Now, the first type is a dynamic DNA. At one time, all the DNA records had to be manually entered into the DNA server and then edited manually when changes occurred. For example, earlier, let's say there were 10 websites and there were 10 domain names and there were 10 IP addresses. It was simple at that time, right? But today there are millions of websites on the internet and the DNA administrator can't just add and remove and delete and update the DNS records manually. It is a hell lot of tedious task to do all those things manually. And therefore, today, Domain Name Server is a dynamic server and works in a consort with DHCP function. Hosts register their names with their DNA server as they receive their IP address configuration from the DHCP server. Some older operating systems are not capable of self-registrations, for example, Windows NT, but the DHCP server can even be configured to perform the registration on behalf of these clients with their DNA server. This doesn't mean that manual records cannot be created if desired. In fact, some of the record types that we have discussed should be created manually. That is the Middlesex record and the CNAME record, that is the canonical name record. The next type of the DNS is internal and external DNA. DNA servers can be located in the demilitarized zone we have seen earlier or inside the intranet as you can see on the screen. When located in the demilitarized zone, the DNA server should only contain the records of the devices that are placed inside the DMZ. Implementing separate internal and external DNA servers might require you to include external resource records. Now, you need to know this when the Active Directory Forest Truth uses the same DNA name as the external network, or when you want to reference the externally accessible resources by their true IP addresses. Well, don't worry, this is a lot of things. You actually don't need to know the different types of DNA. I just told you because it is my duty to provide all the knowledge that is required for you to crack your interviews. Well, that's it folks. We have successfully completed the networking devices of DNA servers. Wait. There are other networking devices as well, but those are pretty simple and you just need to understand the basic working behind them. Again, if you're really enjoying this course, I would like to request you to please rate our course and I'm waiting for your rating to be appeared on the screen. So in the next lecture, I will tell you of one of the most interesting servers that we keep using all the time. That is the proxy server. Okay, so now that we have completed the domain name system server, that is the DNS server, now let us move on to the proxy server. A proxy server is basically a type of a server that handles its client machine request by forwarding them on to other servers, allowing granular control over the traffic between the local LARIA network and the internet. Now, when it receives a request, the proxy server will then connect to the specific server that can fulfill the request for the client that wants it. A proxy server operates at the application layer. So a proxy server operates at the application layer. Well, that went far away. Let me just erase it and I'll try to draw a straight line this time. So application layer. Okay. Yeah, fine, that's it. Sometimes. Now the proxy server modifies the client's request or a server's response to it, or even it handles the client request itself. So it modifies the client request. Now it will actually cache or remember the specific server that would have normally been contacted for the request. Now basically, proxy server helps in limiting the availability of sites that user can access. For example, let's say this is your machine. This is the proxy server and you want to communicate through this server. Okay, this is the server. Now, what will proxy server do? In this case is, now instead of forwarding the directly to request to this, what your machine using the proxy server does is first you transfer the request to the proxy server and then the proxy server transfers the request to the main server, so it acts as in between in case of ethical hacking. Also, proxy server plays an important role because in ethical hacking, we use a tool called as burp suite, which is actually a proxy modifier. It acts as a proxy, and instead of sending the request directly to the main server, the burp suite captures the request from the client and then you can modify the request to test the vulnerabilities present in the direct server. Now, make sure that there are 3 major types of proxy servers. So the first type is, so let me choose the Pena. The first type is web proxy server. Now, a web proxy server is usually used to create a web cache. You experience this when you Google a site you have visited before, right? The web proxy remembers you and the site not only loads faster, it sometimes even recalls your personal information by automatically filling in your username. You can try this. Let's just visit to Amazon or Amazon.com and fill your details and quit. And after some time again try to visit the same site. The details get auto-filled. The next is caching proxy server. A caching proxy server is basically a server which speeds up the network's service requests by recovering information from a client's earlier request. Now, caching proxies keep local copies of the resources requested often, which really helps in minimizing the upstream use of bandwidth. These servers can greatly enhance the network performance. And finally, the last type of the proxy server is reverse proxy server. Now, I would like to mention one more thing about reverse proxy server is that unlike the forward proxy server that is a normal proxy server, reverse proxy takes requests from the internet and forwards them to servers in an internal network. Whereas the forward proxy we discussed in this lecture takes client requests and then sends them to internet. Earlier, I mentioned a tool called as burp suite. I guess you must have listened. Yeah, so burp suite acts as forward proxy as well as reverse proxy. Now, if you want to learn more about burp suite, do not forget to check our ethical hacking course and bug bounty courses, in which you'll gain complete knowledge of how to hunt bounties and earn rewards. My students have earned in thousands and dollars of rewards. Even I am a bug bounty hunter, but mostly I do as auditing. This current it will pass for 2 to 3 years. But yes, bug bounty hunting is a growing field. I've done a low T of bounties I've earned and helped clients. But yeah, again, not going far away from the subject. If you want to know more about proxy servers, how they are used in ethical hacking, do not forget to check our course. That's it for a proxy server. I hope you have a basic idea. So a proxy server is basically a server which acts as a middleman. Instead of trying to communicate directly to the main server, you communicate to the main server through a proxy server. Now, in the next lecture we are going to talk about encryption devices which are used in the internet work. Okay, now let us talk something about the encryption devices. Although a number of the devices we have discussed earlier can perform encryption services, there are dedicated appliances that can perform encryption as well. The advantage of using these devices is that they normally provide more choice of encryption methods and stronger encryption options. They also offload the process from other devices like Routers and services, which has a good thing because encryption and decryption process is a very tedious intensive process and it involves other functions that routers and servers might not be performing. Sometimes these devices are called as encryption gateways. As you can see on the screen, this is an encryption appliance. They can either sit in the line with the local server, encrypting and decrypting all the traffic, or they can function as an appliance or application server, encrypting any file that is sent to them within a network. Now you can see the examples of the encryption devices on your screen. While an encryption appliance is dedicated to encryption, a content filtering appliance scans the content of what goes through it and filters out specific content or content types. Now, dedicating a device to this process offloads the work from the servers or routers that could do this, but at a cost of greatly slowing the devices. Also, there is usually more functionality and granular control available with a dedicated appliance, and that is why we employ encryption devices in our network. Email is a good example of what you might run through one of these devices to filter out spam and objectionable content before the email is delivered. Another example of the use of a content filter might be to block basic websites based on the content of the web pages, rather than on the basis of the URL or IP address. An example of a dedicated content or URL filtering application from security point of view is shown on the screen. That is the DNA 120 rare view. In the next lecture we will talk about analog modem. So I hope this lecture was pretty clear. The basic function of the encryption devices is to encrypt and prevent the data from malicious use. Or to just filter out packets. That's it. Now, in the next lecture we'll talk something about the analog modem. So now in this lecture I'm going to explain in short about analog modem, packet shaper and VPN concentrator. Now, for this course, you do not need to know in detail of these working of these devices. You just need to know what and how these devices work and what are they basically used for. So, what is an analog modem? A modem that is modulator and a demodulator combination of these both. So, a modem is a device that modulates an analog carrier signal to encode digital information and then demodulates the signal to decode the transmitted information. I gave you an example of this when I explained the access points earlier in the section. Because an access point modulates and demodulates a signal just like a modem. A figure on the screen shows a current analog modem that can be used here in today's network, although it's slow throughput. So in short, the goal of analog modem is to produce a signal that can be transmitted easily and decoded to reproduce the original data back occur. These signals are transmitted over telephone lines and demodulated by another modem at the receiver side in order to read the digital data. Because modems connect to phone lines, the location and installation of these devices is fairly cut and dried. It will have to have a near phone line, with one end connected to the phone line and another to a computer modem bank. The analog modem operates at layer 1, that is the physical layer, just like a repeater. Next is the packet shaper. Now, packet shaping, also known as traffic shaping, is a form of rate limiting, an internet traffic management technique that delays some or all the packets to bring them into a compliance with you or your company's traffic profile. The figure on the screen shows a dedicated packet shipper from a blue coat, a company blue coat. So yeah, this process is to use to optimize the guaranteed performance, improve latency, or increase usable bandwidth for some kinds of packets by delaying other kinds decided on by you. And the last device of this lecture is going to be VPN concentrator. A VPN concentrator is a device that accepts multiple VPN connections from remote locations. Now, although this function can be performed by a router or a server, as with the encryption gateways and content filtering devices discussed earlier, the same performance benefits can be derived from dedicated A specific device should be dedicated to this, and this device is nothing but the VPN concentrator. Moreover, additional functionality usually comes with these devices, one of which is shown in the figure on your screen. Well, that is it. I hope you understand the meaning of analog model, which is used to modulate and demodulate a signal. Then packet shaper is to limit the number of packets, and VPN concentrator is to provide the VPN connections from remote locations. Multiple VPN connections from remote locations. Well, that's it for this lecture. In the next lecture we are going to see about the media converters and voice over Internet Protocol modems. That is the VoIP devices. Well, now in this lecture we are going to talk about the media converters and next generation firewalls. We have actually talked about firewalls in the earlier sections, but I had kept next generation firewalls, that is NGFW, for this lecture. Okay, so media converters are used when you need to convert one type of cabling to another type. This might be required to convert from one type of fiber to another, or from Ethernet to fiber. For example, a figure on your screen shows an Ethernet to fiber conversion box. Obviously, the location of these devices depends on where the conversion needs to take place. Media converters operate at layer 1, that is the physical layer. Now the next is next generation firewall, that is NGFW. Next generation firewalls are a category of devices that attempt to address traffic inspection and application awareness shortcomings of a traditional stateful firewall without hampering the performance. Now, although devices also attempt to address these issues, they need to use a separate internal engine to perform individual security functions. Well, this means a packet may be examined several times by different engines to determine whether it should be allowed into the network. Now, next generation firewalls are application aware, which means they can distinguish between specific applications instead of allowing all the traffic coming in via typical ports. Moreover, they examine packets only once during a deep packet inspection phase, which is required to detect malware and anomalies. Well, that's it. We have completed all the networking devices that you needed to know for this section. In the next lecture, we will just see the benefits of routers. And finally, we'll conclude this section by having a quick recap and what you actually need to remember from this section. And I will tell you about a next section which you're going to study. So I'll see you in the next lecture, where we will discuss a few benefits of routers. And why do we need routers in an internet work? Now, let us conclude this section by talking something about routers. Okay, routers are used to connect together and to route packets of data from one network to another. Cisco has become the de facto standard for routers because of its high-quality router products, great selection, and fantastic service. Routers, by default, break up a broadcast domain. Now, breaking up a broadcast domain is important because when a host or a server sends a network broadcast, every device on the network must read and process that broadcast unless you've got a router. So when a router's interface receives this broadcast, it can respond by basically saying thanks, but no thanks, and discard the broadcast without forwarding it on the networks. Now, even though routers are known from breaking up broadcast domains by default, it's important to remember that they break up collision domains as well. So in short, routers are the devices which break broadcast domains as well as collision domains. Now, there are a couple of disadvantages and advantages as well. But first we'll see advantages. Routers do not forward broadcasts by default or multicast packets. Now, routers use logical address in the network layer header. Then routers can use access lists to control security on the type of packets. Routers can provide layer 2 switching. We all know that, so that's it for this lecture. In the next lecture, in the last lecture of this section, we will have a quick recap and summary of what we have seen and learned in this section. So now let us begin with a brand new section of network security. Let us have a look at what you are going to learn in this section. So first we'll learn about the security filtering technique, in which we'll learn about access control lists, tunneling and VPN, that is, a virtual private network. Then we'll see the SSL and TLS protocols, which are very important when it comes to network security. Then we'll see encryption algorithms like AES to Cs. Then how to manage user accounts and password security. Then what are the rules for password management, digital certificates and PKI. And finally, overview of identity access management. So this section is going to be a long section, and it is going to be a very interesting section. So let us get started with the first topic of security filtering. So far you have learned a lot about networking standards and related technologies, and even know how to make computers and devices communicate so that you can get a network up and running. But there's more. Because network security is absolutely critical, I'm going to equip you with the knowledge you need to keep your network safe from hackers. Yes, communication and accessing the information you need is all good, but knowing exactly who is at the other end of the connection is also vital. This means that you need ways to confirm that the person or the computer at the other end of the connection is really supposed to be accessing the resource it's trying to, and even whether the resources or the entities that you are contacting are really who and what they appear to be. Seriously, if you don't have network security firmly in place, you are flying dangerously blind. You could be inadvertently exposing critical data to people who have no right to see that information and may even intend to exploit it in a big way. So in this section we'll focus on some very important pieces of the security puzzle. The first things that are security filtering and user authentication. Now, how do we know who is really at the other end of our connections? The answer to that may seem simple enough, because the computer or the person on the other end must identify him or herself, right? Wrong. That's not good enough, because people, especially hackers, lie. So it's totally naive to assume that person or computer on the other end of the line is who they are claiming to be. Sad but true. Hackers use many tools out there today with the precise goal of convincing us they are someone else. That is, they try to impersonate people. And we all know that someone has been a victim of this, and they have failed to identify theft. And that is why, thanks to the bad guys with the right spoofing software in hand, which helps us making easier to identify them, this means it's imperative to control who or what can get into a network by identifying the specific computers. Well, for the starters, I'm going to cover some basic ways to safely allow the computers you want to have access in your network, plus keep the ways out of the ones you honestly don't want people to. The first line of defense is something called as security filtering, which broadly refers to the ways to let people securely access your resources. This process is twofold, and it includes ensuring that only authorized computers get entry to your network, making sure that the data you are sending back and forth between the networks is secured so that it can be intercepted and translated by bad guys. Sorry, it cannot be intercepted by bad guys. And that is why we need security filtering and the idea of network security. So this was it for this lecture. So the basic idea of security filtering, as the word suggests, is to disallow bad guys from entering into your network and not allowing them to tamper with your data. So there are various security filtering techniques like access control lists, encryption, which we are going to see in this section. So let us get started with the next lecture. So let us begin with the first security filtering technique, that is access control list. It's rare to find a network around these days that aren't connected to the internet. The internet is clearly a public internet work that anyone can connect to, but your company's or personal network is and should be definitely a private one. The catch here is that every time you connect to the internet from a public network, you're instantly vulnerable to security break-ins. Now, this is where something we call a firewall comes into play. Firewalls are basically tools that you can implement to prevent any unauthorized access around on public networks and gaining access to your network. Firewalls can either be standalone devices or combined with another hardware device like servers or routers. Now, access control list is the primary weapon of the firewalls, which help us to discard unused packets. Now, access control list, that is ACL, is typically not kind of a list. It's kind of a program that resides on the routers to determine which packets are allowed to route through them based on the requesting devices. Source or destination Internet Protocol address, that is, the IP address. Oh, and just so you know, ACLs have been around for many decades and have other uses apart from firewalls as well. Now there's an image on the screen which demonstrates an ACL-enabled router. Okay, so what we can see here is, I'll take my pen. What we can see here is that users in the network A, that is, can access network B. Right? So the packets that can pass through the router are from this way, from network A to network B. Now this means that an IP spoofing attack, when someone pretends to have a network address on the inside of the firewall to gain the network access, can still happen if a user in the network B pretends to be located in the network A. So for example, someone who is here but it is pretending to be here can also access the internal network because it is pretending that it's actually residing here. Now, we'll see things like IP spoofing more thoroughly in other sections of network threat and mitigation. But for now, let's go back to ACL. So which means B can access A if a secure authentication connection is, so B can actually access A only if a secure authentication connection is used, for example HTTPs, but it can access the public network. Now, you can create a wide array of access control lists, from the very simple to the highly complex, depending on the exact what do you exactly want to have them to do for you. One example is placing separate inbound and outbound access control lists on the router to ensure that the data that is leaving your network comes from a different source than the data that's coming into it. Now, when configuring access control lists between the internet and your private network to mitigate security problems, it is a good idea to deny any address from your internal networks, then deny any local host addresses, that is, deny any reserved private addresses, deny any addresses in the IP multicast address range, that is 224.0.0/4. Now, none of these addresses should ever be allowed to your internetwork. Interestingly enough, because of the way in which public IP addresses are issued, with some research, you can even create a filter that blocks a country, a state, or even a local area based on the IP addresses. If you want to know more about access control list, I guess I have already attached some resources at the beginning of the section. If I have not, please post a question and answer in the question answer section. I will immediately upload the book. Well, that is it for this lecture. Now I hope you have understand the function of access control list and why access control lists are important. Another technique of security filtering is MAC address filtering and port filtering, in which you discard and allow packets based on the MAC address and the ports. That is the incoming ports on which the data is getting received. Now, most of the time, it's wise to configure the access control list so that they'll allow or deny access based on the IP address of the source or destination device. Generally, we allow or deny IP packets based on the IP address from where they have received. Now, if your network is running on protocol other than the transmission control protocol or the Internet Protocol, that is TCP, we can filter the traffic based on media access control, that is the MAC address or the hardware address. We have seen the hardware address in our networking sections. If you haven't seen the MAC or IP address, or if you are confused about the MAC, please refer to the computer networking course in which I have discussed everything about these addresses. Now, we can still use a MAC address-based access control list if we are running on the TCP/IP, but I would like to tell you that it's a lot easier to deal with the IP address than the MAC address. Another point to remember is that even though most firewalls and routers still allow you to create both IP-based and MAC-based access control lists, doing so can create an exceptionally ugly situation where access is denied when it really shouldn't be. So when it comes to MAC filtering or IP filtering, just make sure that you stick to only one of these because it is a lot easier to deal with IP address filtering. Now, the next thing is port filtering. Access control lists can also be used to filter based on the port numbers as well as the IP address. In fact, the most firewalls, by default, allow only open ports that we specify. This is another version of the implicit deny. That is, anything not allowed specifically is denied. When managing a firewall, it is important to know the port numbers of all the traffic that needs to be allowed through it. If you do not know the port numbers on which you want to allow the traffic, there's no use of having a port filtering technique. You can't just randomly allow and disallow the port numbers. Now, this means that for some of your application, you will need to read and learn the port numbers being used. This also explains why it's a big deal to know the port numbers of security protocols like SSL and IPsec. Successful management of firewall involves being aware of it and allowing only the ports to keep things running. For example, if you want to place a firewall on your network and if you do not know which ports the traffic is actually sending, and if you randomly on or off, make off the port, there is no point in port filtering. So make sure before you apply port filtering in your networks, you first must be acquainted with all the port numbers on which the protocols are using. That is it for this lecture. We have studied about the MAC filtering and port filtering, which are another two techniques of security filtering. Just thinking about the huge amount of sensitive data that is bouncing all over the internet 24/7 makes me want to scream the word security. It is seriously clear that we need it almost as much as air, right? I hope you understand. Worst, most of that data is sent out over the internet without any encryption or any security measures, but at least not really the sensitive stuff, which should be sent by one of the several different security protocols available today. Now, these vital protocols are really sets of conditions or rules that define how a secure connection is maintained and when we send sensitive data through an insecure medium like the internet or a wireless connection. Before talking about the security protocols that the network exams or any other placement interviews you can ask on, I'd like to define a few terms. The first one is tunneling. Now, tunneling is basically a means of encapsulating one protocol with another protocol to ensure that the transmission is secure. Now, let's give an example. The last science share of us use IP protocol. That is the Internet Protocol, known as the payload protocol, which can be encapsulated within a delivery protocol like the IPsec. If you take a look at these individual packets, you would see that they're encrypted. If you look at the process as a whole, it appears that a point-to-point tunnel is created over the internet. Now, make a note to yourself that usually tunneled protocol works at the higher layer than the layer in which the payload protocol is working. So basically a tunnel is like this. So if you can see here this image. So I'll take my pen. This tunnel is basically the IPsec protocol, and these are the data packets that are going through the Internet Protocol. It's like a protective measure so that hackers or the interceptors cannot have your data. And generally, this together is encrypted and then sent over. Or you can just encrypt this packet and send through the IP protocol. This is the basic idea of tunneling. You just have to imagine a tunnel and the cars going through it are the individual packets. And if someone tries to attack the tunnel or someone tries to harm that car, the tunnel is there to protect those cars. That is the basic idea of tunneling. In the next lecture, we'll see about the virtual private network. I'm pretty sure that most of you use VPNs, but in the next lecture, let us have a clear idea of why do we need to use VPNs and what are exactly VPNs. Okay, so now, let us start with VPN. Now, no worries, virtual private networks aren't really that hard to understand. I'm going to explain in really simple words. A VPN, that is a virtual private network, it fits somewhere between the local area network that we are connected to and the wide area network that connects two or more LANs, and many times may seem just like a link because your computer on one LAN connects to a different remote LAN and uses its resources remotely. That is the basic definition of a VPN. Now, the key difference between the virtual private networks is a big one: security. So the definition of a connecting a LAN to a WAN may sound the same, but VPN is much more secure. Now, here's the difference. A typical wide area network connects two or more remote local area networks together using someone else's network, like say your internet service provider and a router. Your local host and router see these networks as remote networks and not as local networks or resources. This would be a WAN in its most general definition. So a VPN actually makes your local host part of the remote network by using the WAN link that connects to the remote LAN. Now, the VPN will make your host appear as though it's actually local on the remote network. This means that we now have access to the remote local area's resources, and that access is very secure. This may sound a lot like a VLAN definition, that is a virtual LAN. That is, take my host and make it appear local to the remote resources. Just remember that for networks that are physically local, using virtual LANs is a good solution, but for networks that are physically remote, those that span a wide area network, VPNs is the best solution. For a simple VPN, let's use a home office in a country or a city. And on the screen, you can see this figure. So what basically here is going on, I am sending data to someone on the internet through a tunnel. Now, this is a preventive tunnel through which I am sending the data, and whoever is trying to access is getting rebounded. So neither hacker nor the government can see what is sending between the data. And that is why many people use virtual private networks. Now, in some cases, let's say if you're watching a Netflix movie, now, if you are from India or from US, some movies of, let's say, European countries are not allowed to be broadcasted in your country. So what most people do is they make use of VPN. Which means that suppose this is Netflix and this is you are trying to directly access Netflix, but you are not able to do that. So I'll use this. So if you are trying to use Netflix, you are not able to do that. So what you do is you access Netflix through this country, this ISV of let's say US, and then this ISP sends packet to the Netflix. And let us say this ISP is from a country where the movies are allowed to broadcast. So what is this here? So what does this Netflix thinks that, okay, the packets are received from European country and now I can permit. So this data is again transmitted to the ISP of the country in which the movie is allowed. And again, this ISP sends the data back to you. So in this case, instead of this channel, they can use a VPN here. So what actually the user or you do is you use a VPN here, a virtual private network through which the data is getting transferred. So now there are different types of VPNs. Now why is this so important now? Because the types of VPNs are named based on the role they play in the real-world business. So the first one is client-to-client virtual private network, which is also known as remote access virtual private network. Now, a remote access virtual private network allows remote users like telecommunicators to securely access the corporate network wherever and whenever they need to. It is typical that users can connect to the internet but not to the office via their VPN client because they don't have the correct VPN address and password. This is the most common problem and one should always check first before trying to access the resources. The next one is host-to-host VPN. A host-to-host virtual private network is somewhat like a site-to-site in concept, except that the endpoints of the tunnel are two individual hosts. In this case, all the traffic is protected from the time it leaves the network interface card of one host until it reaches the network interface card of the next host, which means if you are trying to communicate with your friend and if you are using a VPN, that is a host-to-host virtual private network. Site-to-site virtual private network. Now, site-to-site VPNs, or also known as intranet VPNs, allows a company to connect its remote sites to the corporate backbone securely over a public media like the internet. Now, instead of requiring more expensive area, that is the wide area network connections, this is probably the best solution for connecting a remote office to a main company. So if someone asks you, how do you connect your remote office to the main company headquarters? The answer is site-to-site virtual private networks. And the last kind of VPN is extranet VPN. Extranet VPNs allows an organization, suppliers, its partners, and its customers to be connected to the corporate network in a limited way for only business purposes. So these are the types of VPNs that you need to remember. From the exam point of view or any exam you're going to appear or interview you're going to appear for, just make sure that you remember the definition of VPN. Why do we require VPN? The answer is for security purposes. And just remember the 4 types of VPNs that we have just discussed. That is it for this lecture. Now, let us have a discussion on secure sockets layer and how SSL and VPN works together. Well, what is SSL? For time being, just ignore the picture. Focus on what I'm going to tell you. Now, next on the list is the secure sockets layer. Now, this security protocol was developed by Netscape to actually work with its browser, and it is based on Ravist, Shamir, and Edelman, that is the RSA encryption algorithm, which is a public key encryption, and it is used to enable the secure session connections over the internet between a web browser and a web server. Now, SSL is service independent. What is the meaning of service independent? It means that a lot of different network applications can be securely connected with it. One of the famous being the ubiquitous HTTPs, that is the hypertext transport. You got it, right? Hypertext Transfer Protocol, HTTPs, Hypertext Transfer Protocol. There is no transport word, I was checking on you. So HTTP uses SSL to get the HTTP's protocol. Now, as time marched on, SSL was merged with other transport layer security protocols to form a new protocol that is called as Transport Layer Security TLS. And the latest version of TLS is TLS 2.0 and it provides a number of enhancements over the earlier versions. Now, several improvements in the operation of the main component of encryption was weighed. The MD5 or the secure hashing algorithm SHA was being introduced. Hashing functions are used by SSL to ensure that the data is not changed or altered, preserving the integrity of the data, which is one of the most important elements of information security integrity. Now, more flexibility in the choice of hashing and encryption algorithms on the part of the client and server are also supported by SSL, and it has enhanced support for the advanced encryption standard that is the AES algorithm. Now, what as you can see on the screen, I forgot this. This is an SSL connection process. The first thing here, I'll use my highlighter laser pointer. The first thing here is connection request. The PC or the host sends a connection request to the server. Then the server asks if you do need a secure connection. Okay, I'll provide with all the security capabilities. And finally, the SSL connection is established. Now, SSL VPN is really the process of using the secure socket layer to create a virtual private network, alright? A VPN is a secured connection between the two systems that would otherwise have to connect to each other through a non-secured network. Now, here's what I mean. Listen carefully. Now, even though I'd never really let this happen, but let's just say I could connect to the servers in my corporate office through the internet, okay? Now, you know by now that this would be a very bad thing because the internet is not at all secure, right? But if I connected to all those servers using a virtual private network with a tunneling protocol instead, anything that I send from my PC to my corporate office would be locked up nicely and securely, right? Plus, VPNs come in handy for the data that's being sent within a private network that you probably wouldn't want everyone on the network to be able to see. Maybe you want a specific computers on the intranet to be able to communicate with each other securely, like, let's say, the computers used by your top finance people. Now, you wouldn't necessarily want that data just sent off in the clear to be viewed by the office gossip, now would you? No way, so you can put those finance folks on a VPN. That's just like having them on their own little private network. Plus, what's even cooler about this setup is that the members of your intranet VPN can still communicate with everyone else whenever they want. So why not use a VPN? So here's it. You can see the server in the SSL VPN gateway. Here is the clear text communication. But when a client wants to connect through the internet to your server, it uses an SSL VPN communication which provides more security. So that is it for SSL and VPN. Just make sure that you understand why VPN is used alongside with SSL. It is literally a process of using SSL to create a private network. So that is the use of SSL and VPN. Well, that is it for this lecture. I will see you in the next lecture. Now let us have a look at some interesting security protocols or tunneling protocols. The first one is Datagram Transport Layer Security Protocol. That is DTL's protocol. Now, this protocol provides security for datagram-based applications by allowing them to communicate in a way that is designed to prevent eavesdropping, tampering, or message forgery. So basically, this protocol is meant for mitigating basic security attacks like data tampering or data forgery. Now, it is based on the Stream-Oriented Transport Layer Security Protocol. That is the TLS protocol, and it is intended to provide similar security guarantees. The next protocol is Layer 2 Tunneling Protocol. Now, Layer 2 Tunneling Protocol, it was created by the Internet Engineering Task Force. That is the IETF. It comes in handy for supporting the non-TCP/IP protocols in VPNs over the Internet. Now, L2TP, that is Layer 2 Tunneling Protocol, is actually a combination of Microsoft's Point-to-Point Tunneling Protocol (PPTP) and Cisco's Layer 2 Forwarding Protocol (L2F) protocol. Now, a nice L2P, that is Layer 2 Truth-Link Protocols feature is that because it works way down there at the data link layer of the OSI model, that is the Layer 2. It can support tons of protocols beyond just TCP/IP. For example, Inter-Network Packet Exchange, that is IPX, and the Apple Tech. It's really a great tool to implement if you have to happen two non-TCP/IP networks that need to be connected via Internet. I just now mentioned about Point-to-Point Tunneling Protocol. That is the PPTP protocol. Now, this protocol was jointly developed by Microsoft, Lucentech, 3Com, and many other companies. It's not actually sanctioned by the IETF, but that doesn't mean it doesn't work. PPTP acts by combining an unsecured point-to-point protocol. That is a PPP session with a second secured session using the generic routing protocol. That is the GRE protocol. Don't worry, I am going to explain GRE in upcoming lecture. Now because PPTP, that is point-to-point tunneling protocol, uses two different protocols. That is PPP point-to-point protocol and the GRE, that is generic routing protocol. Generic routing encapsulation protocol, pardon me. It actually opens up two different network sessions. So be warned, PPT can give you some grief when passing through a router. Now, this is a big reason you find it around nowadays. Another reason it's going the way of the dinosaurs, that is, it is not being used nowadays, is that originally it gained popularity because it was the first virtual network protocol to be supported by Microsoft style in networking services. And not too many of us depend on dial-up to get connected to the internet anymore. That is why the point-to-point tunneling protocol is not being used these days. But as a fact of theory, you should always have knowledge of these protocols, as it was the first VPN protocol supported by Microsoft. Now, another one is, in fact, you'd probably expect from a first-generation security protocol that this protocol is nowadays really vulnerable to spoofing attacks, which is pretty much being replaced by L2P, that is Layer 2 Transport Tunneling Protocol, and the Internet Protocol Secured 1, that is the IPsec. Well, that is it. In this lecture, we have seen three major types of protocols: tunneling protocols, the Datagram Tunneling Layer Protocol DTLS, then Layer 2 Tunneling Protocol L2TP, and PPTP, that is Point-to-Point Tunneling Protocol. I hope you have understood these protocols. If you have any doubt, feel free to answer through the Q&A section, and I will see you in the next lecture. Okay, enough for now. Thanks for being with me till the end of this video. Until the next video, keep cool and stay anonymous.